Welcome to the pre-lab assignment for Analyze Week. Before you dive into the Analyze Week lab, we need to make sure you understand ordinary least squares, or OLS, linear regression analysis. This pre-lab assignment should assist you in understanding how to read the results of the analysis. Make sure to read through this document without the assistance of this video. We will not be covering all important topics. This is just an overview. If you have further questions after this video, please review the links provided in the additional references section here at the beginning of this document. So for this project, we're looking at the socioeconomic factors that could be associated with meth lab density in an attempt to assist law enforcement in understanding crime patterns in their area and social advocacy groups in targeting areas most likely affected by methamphetamines. To do this, we'll be evaluating multiple independent or explanatory variables and the relationship to the dependent variable. The explanatory variables in this case are the census data, the dependent variable being the meth lab data. Comparing these multiple independent variables to the dependent variables known as regression analysis. Specifically in this case, ordinary least squares, or OLS, linear regression. Linear regression models use a similar format as the slope-intercept formula from algebra. This is the y equals mx plus b. The alpha is the y-intercept, the beta is the slope, and the x is the independent variable value, as shown by this equation. When you have multiple independent variables, however, then you will have an equation that's more similar to the one shown here, where each beta sub n is the coefficient for each independent variable, basically the slope. Coefficients will be provided by the output of the OLS analysis and can tell you a lot about how well your model is working. Remember, the closer that the beta, the coefficient, is to 0, the closer the line is to having no slope. If there is little or no slope, then there is little or no relationship. The sign in front of the coefficient will tell you whether the relationship is positive, by having no sign, or negative, having a minus sign. Look at these three graphs. The first shows that as the presence of home foreclosures increase, the number of household units also increase. This is a strong positive relationship. If the independent variable goes up, then the dependent variable goes up. The second shows that if an area has a lot or an increase of unemployment, it likely has fewer or a decrease in the percent of the population that is college educated. This is a strong negative relationship. As the independent variable goes up, the dependent variable goes down. The third shows a very weak negative relationship between the independent variable to the dependent variable. The presence of more college-educated people in an area doesn't seem to have any relationship to how many people are pet owners. Those two variables don't seem to have much to do with each other, according to this data. Take a quick look at the summary of the OLS results table you will be seeing in the Analyze Week lab. The image has a bunch of areas highlighted by numbers. Make sure to read through this section to get an idea of what these things mean. So read through this whole section about model performance, explanatory independent variables, model significance, stationarity, model bias, and spatial autocorrelation. We will review this in a later video, but you need to understand what these values are and why they are important to consider in the 6 checks. The 6 checks, shown here, are what you will perform to determine whether your finalized linear equation, or model, is what it's also called, explains what independent variables help determine, to some extent, meth lab density. These checks will be detailed in other videos, but you should know the overall process of these checks. So for the lab, you will perform the first 3 checks multiple times, over and over again, removing any variables that do not pass them. Once you get through variables that pass the first 3 checks, you will then move on to the 4th check and remove even more variables. The 5th check you will not have to complete for this lab, but it will be good to understand what it is. You will need to discuss it in your report. As for the 6th check, you might remove 1 or 2 variables, but in most cases you've achieved the best fit model at this point. Let's now take a closer look at the OLS summary results table.